Okay, so today we're going to do some mixed sine law and cosine law review. So I'm going to throw a bunch of questions at you today that have to do with both sine law and cosine law, and sometimes maybe even you have to do both in one question, and we're going to get some practice with this. So be prepared. Here we go. So it's going to be a you try, I go over kind of lesson today. I'll post a question, you'll need to try it, and then I'll go over it. Really ensure that you are giving these questions an honest try, because if you're just watching me go over them, you're not going to learn anything from it. You're just going to be wasting your time. So at least give them an honest try. If you totally get stuck, that's fine. Just press play and then watch how I do them. The trick today, however, is the questions are going to be a mix of sine law and cosine law. I'm not going to tell you on each one until I go over it, of course, when to use each strategy. It's going to be up to you to figure that one out. Just as a bit of a recap, though, the only hint I'm going to give you right now is that sine law is used for triangles where you can create a key. So if you are able to create a known side and a known angle across from a known angle and a known side across from that angle, that can serve as a key. If you're able to do that, then you can use sine law. If you're unable to do that, then you got to use cosine law. Sometimes you'll have to use cosine law to find one piece of information and then have to end up using sine law to find the other pieces of information. That's okay. They're not like exclusive to one another. You can use them both in one question. Okay? We'll start with the first one here. Here we go. Solve for angle J. Pause the video here, write this one down, give it a shot, see if you can solve for angle J. All right, so I'm going to go over this one. This question, we only have side lengths, so we can't use a key. In other words, we can't use an angle, a known angle over a known side, because we don't even know any angles. So we have no choice here but to use cosine law. This is going to be the angle we're focusing in on. And I know in cosine law it says cosine A equals yada, yada, yada. Well, this J is going to have to work as our capital A. And then that means this side over here is going to be like our lowercase a, okay? Now, the other two sides can be our lowercase b and lowercase c, and those are interchangeable, as I mentioned before in the last day's video. So just make sure you account for it that way. So we'll say cosine j, instead of saying a in this case. Cosine j is going to equal b squared plus c squared. So 17 squared plus 11 squared. So as long as you're using the sides that aren't the one across from the one you got, minus a squared. Well, a is the side across from the angle you're focusing on, so that one's got to be 10 squared. And then all divided by 2 times BC, so 2 times 17 times 11. Now, I threw this in my calculator all in one go. I was able to put this whole right side in. It gave me a decimal. It was like 0.8 something, I think is what it was. And then you got to take the inverse cosine of that number. Bottom line is the answer you should get is J equals, and I just rounded to the nearest tenth, 34.0 degrees. Hopefully you were able to get that one right, and if you weren't, just make sure you're double checking your answer. If you wrote all this down just fine, your answer or your mistake, if you didn't get this one right, was probably just in some calculations. So just try putting it in your calculator again. Hopefully that'll work. All right, question 2, I'm not giving you a picture. You're going to have to draw this one out. Just remember that the same letter refers to the angle across from it. So in other words, lowercase b and capital B are across from each other. Anyway, in triangle ABC, angle B is 38 degrees, angle C is 56 degrees, and side A is 63 centimeters. Solve for side C. You're going to want to start by drawing a picture here. Give it a try. All right, so your picture could look totally different than mine. I honestly just draw like a very basic triangle. I'll do like something like this, basically. I don't care if the angles are actually to scale or whatever, I just draw it, okay? So I'm going to say that this is angle B. So I'll mark this as being 38 degrees, and I'll say this is angle C, so I'll mark that as being 56 degrees. If this is B, this is C, and it's triangle ABC, then that means this is angle A. We don't know angle A, at least not yet, but we do know side A, and remember side A has to be across from angle A, so we know this one is 63 centimeters. Okay, what we're looking for in this question is side C, which is this side right over here. So this is what we're looking for. Okay, now again, how we go about doing these questions is sine law would require us to have a key. So in other words, a known angle and a known side across from it. The only side we know though is the 63 centimeters, but we don't know this angle. Now usually you'd say, okay, we're hooped, we're just done, we can't do anything from there. But don't give up quite yet. Notice that you have 2 angles that are known. Since we have 2 angles that are known in a triangle, we actually low-key know this other angle as well, because the 180-degree rule just tells us that all the angles need to add up 180. So 180 minus 38 minus 56, that's going to give us the value of angle A, and that value would happen to be 86 degrees. So we know that angle A up here is actually 86 degrees. And now magically we found a way to find ourselves a key. We know a side and we know the angle across from that side. So that's going to serve as our key. Since we're looking for a side length, let's make sure we put side length on the top in our sine law formula. So we'll say 63, this is part of our key, 63 over sine of the angle across from 63, which is 86. So that's our key. Set that equal to what you want. Well, we want a side length C over sine of the angle across from side C, which would be 56. So to solve for C, we just need to times by sine 56 on both sides. I'll spare you the trouble. I'll throw it in all at once. And then I just round it to the nearest tenth. It's just a good thing to round to. 52.3, and then the units on that, of course, because it's a side length in this question, centimeters. So again, hopefully you were able to get that one right. If you weren't, please reach out and let me know. There's no way for me of knowing without you telling me. There's no shame in it either. I'll just help you out. We can even go over some of these questions during the Zoom this week if you want. Up to you entirely. Anyway, let's move on to the next one. Solve for angle N. The only disclaimer I'm going to give you here is this one's a longer question than most of the other ones. It is possible though. Give this one a shot, see what you can get. Okay, so if this question totally stumped you, don't feel bad because this question is really tough. This is one of the questions that have more than one step to them. So here's what you got to do first. First things first, when I look at this, I go, okay, can I make myself a key here? Well, we know this angle. We don't know this side though. And then we don't know either of the other angles, so we can't do anything. So no, we can't get a key. That's telling us no matter what, we're going to have to start this question using cosine law. Now, the thing with cosine law is, though, cosine law relies on having an a and a lowercase a that are across from each other. And ideally, at least one of them are known. And in this case, the only angle that we know at all is 41 degrees. Okay? Now, you could try to say that this angle was your focus angle in cosine law. But then what you would find is you wouldn't have either your B or your C, because your B or your C are just your adjacent sides. So what I'm getting at here is you're going to need to use cosine law. Just bear with me on this. You're going to need to use cosine law to solve for this side. I'll call it side lowercase l. Okay? The reason you're going to want to do that is if you can find this side, suddenly you've now made yourself a key that you can use with cosine law, because you will know this angle and you'll know this side. So to solve for this side here, I'm going to use the version of cosine law that has sides all by itself. So I'll say L squared equals, and then of course it's B squared plus C squared. So B and C are just your other two sides. So 29 squared plus 13 squared. And then minus 2 times B times C times cosine A. So 2 times 29 times 13. And then times cosine A, well, A in this case in reference to this or this side length L, it'll actually be L that we're dealing with here, so times cosine 41. Now I kind of broke this down into little bits. I did this piece first, so I got L squared equals 29 squared plus 13 squared is 1010, minus, then I multiplied all these together, not including the cosine, no, I got 754 times cosine 41. Then I threw this in one next step, and then I square rooted both sides. So I got L is equal to 21.0 millimeters. That was a rounded answer. I just had to round up to the nearest tenth. So 21.0 is that value right there. But we're not looking for that. We're looking for N. So you're thinking, what on earth are we doing? Why do we care about solving for this side length? Well, now let me show you. Notice now we know this angle, and we know the side across from it. That's a sine law key right there. And since we're looking for an angle, let's put angles on the top. So let's write our key first with an angle on the top. Sine of 41 over the side across from it, which we found was 21.0, equals sine of what we're looking for, so sine of n, divided by the side length across from n, so divided by 29. To solve this now, we just need a times by 29 on both sides. That's going to give us a really obscure answer on the left side of the equation, and then we need to take the inverse sign, or sine -1, to get rid of the sign here. What I got, though, was n is equal to, and then I just did it to the nearest degree, n is equal to 65 degrees. And there you are. Whew, okay, so that was a very tough one. Again, if you weren't able to get that one, don't kick yourself, but just understand that sometimes you need to use cosine law first. That allowed us to get a key, and then we were able to use sine law. So hopefully that'll help. All right, last question, question 4. Solve for the measure of side A. I'll give you a hint here. Remember, side A is across from angle A. We're looking for this side length. Pause the video here, give it a try if you can, and I will show you how to do it in just a moment. So if you gave this a try right now, all I have to do, or rather all I have to say to you right now is psych. There's nothing you can do about this one. If you were scratching your head about this one, too bad. There was nothing you could do about this one. Now, if you didn't like pause the video, then you're probably finally getting a last laugh here. But shame on you. You should have paused the video and given this one a try. I'm very disappointed in you, whoever's watching this now. Basically, what you're seeing here is the only thing we know in this triangle are the angles. That doesn't tell us anything. There is nothing we can do. We certainly can't do sine law because we can't get an opposite pair. And then we can't even do cosine law because notice that cosine law requires us oftentimes to use like a b squared and a c squared and all that. So we need to know some sides to even start working with that. Another thing we could say about this is angles are just relative, right? So that like an angle could be this big, but I could make this triangle with the exact same angles, except like make it that big, right? There's 78 degrees, 57 degrees, and 45 degrees, right? So in other words, I could like make this way, way bigger, but keep my angles the same. So who knows what on earth these sine lengths are? This one is impossible, so we'll just say it was a trick. It was a trick question. So sorry about that. I did that on purpose though, because I want you to realize not all triangles are actually solvable. Even if you're given 3 things, like everything else, sometimes it's just not possible when you have angle, angle, angle triangles, okay? Anyway, again, sorry about that, but the more you know. All right, so for practice, complete any remaining questions in your note booklet or in your Chapter 7 assignment. And as always, make sure you're reaching out to me if you have any questions.